Hi everyone. Today we will discuss enhanced FastConnect redundancy with RPC as a backup and the implementation of two FastConnect links per region using equal cost multipath. We will refer to the network diagram displayed on the screen and will concentrate on the configuration of the DRG rather than on the resources needed for the end-to-end connectivity. To begin this configuration, click on the menu icon on the OSA console, access the networking menu, and select Dynamic Routing Gateway under Customer Connectivity. Click on the DRG name, in my case Phoenix DRG because I'm in Phoenix region. Go to Attachments tab. As you can see, all my attachments have the auto-generated DRG routing table. I will go to the Routing tab to verify how the routes are displayed in the auto-generated routing table for the VCN attachment. For this, I will click on the name of the routing table and then on the Get All Routes button. As you can see, the on-premises CIDR block has a conflict on the virtual circuit 2. I will perform the same verification for the auto-generated DRG routing table for the RPC virtual circuits and IPsec attachments. Here, I can see only the VCN CIDR block. Since the auto-generated routing table isn't suitable for this scenario, I have prepared custom routing table with an import route distribution for each type of attachment: VCN, RPC, and virtual circuit. For the VCN, I have included a match all statement. For the virtual circuit, I have a statement to import both VCN and RPC attachments. And finally, for the RPC, I have statements to import VCN and virtual circuit routes. Now, let's verify the routes in the routing tables for these custom routing tables. The VCN routing table is still showing the conflict, and that's because we did not activate the ECMP. To do that, click on Actions, then Edit, and toggle on the Enable ECMP button and save the changes. Now, I will verify again to see what routes are displayed in the VCN routing table by clicking Get All Routes. As you can see, after refreshing the routing table, the conflict disappears. Next, let's look at the virtual circuit routing table. As you can see, we can see the VCN and RPC routes. The last routing table I will verify is the RPC routing table. It looks like we still have a conflict. I will activate ECMP on this routing table and verify again. It looks like after enabling ECMP, the conflict is gone. Now, it's time to change the routing table used for each attachment. First, go to the Attachment tab. Click on the VCN attachment name. Click Edit in the top right corner. And under DRG routing table, select the custom routing table for the VCN and click Save Changes. Next, I will quickly make the same changes for the other attachments, the two virtual circuits and the RPC. Now, the configuration in the Phoenix region is complete. I will switch to the San Jose region and apply the same configuration there. Since the DRG configuration in both regions is now complete, I will proceed to the VMs I have to conduct some tests. First, I will perform multiple trace routes from the Phoenix VM to on-premises VM. Next, I will perform the same test from San Jose VM to the on-premises VM. As you can see, in both region VMs, the second hop of the trace route test is different, indicating that the path taken is balanced between virtual circuit 1 and 2. The next test I will perform is a MTR from the on-premises VM to the Phoenix and San Jose VMs. As you can see, in this test, hop number 5 shows the BGP address of the virtual circuit that has the traffic flow. Now, I will go back to the OCI console and disable BGP on the virtual circuit 1 in each region. With the virtual circuit 1 disabled in both regions, I will wait for it to return to the provisioned state. Once the virtual circuits are back on the provisioned state, I can see that the BGP sessions are down and I can redo my test from the VMs. As you can see, the MTR test shows packet loss on the intermediary hops, but there is no packet loss at the destination. I will restart the MTR test, and now you can see that hop 5 shows different IPs, which correspond to the BGP of the virtual circuit 2. I will also redo the traceroute test from the Phoenix and San Jose VMs. As you can see now at hop 2, we can see the same IP that corresponds to the BGP of the virtual circuit 2. With this, the DRG configuration and tests are complete. Thank you for watching and happy networking!